You may recall from an earlier video when we talked about an equivalent model for an operational amplifier that the op-amp itself is really a differential amplifier. In other words, it takes the difference between the voltage at the non-inverting input and the inverting input, V plus minus V minus, if you will, and amplifies that by some factor A to generate the output. The problem with this is that the amplification factor is typically in the hundreds of thousands. So this means that the difference between your two input voltages has to be really small, on the order of microvolts. This is often inconvenient at best, shall we say, and is subject to problems like serious noise issues and all of that. So it would be helpful if we could design a circuit where the difference in our two voltages of interest is not quite so small. The circuit shown here gives us a generic differential amplifier, and we can adjust the four resistance values to basically give us whatever values we want. Your basic differential amplifier says that V out is some amplification factor times V1 minus some amplification factor times V2. Now those two amplification factors don't necessarily have to be the same, although that's an important case. But in the general case, you can set two different amplification factors by selecting these four resistors. That can get to be a little bit complicated, as can the analysis of this. Your book does a pretty good job of going through the analysis and deriving the final form, which is a little bit clunky, but I will let you look at the book for that. The important case where you have a differential amplifier where you've got some common amplification factor, A, times the difference in V1 and V2. In other words, A times V1 minus V2 is a very important case, so we are going to look at that one specifically. This one is pretty easy, and if you simply make the two input resistors some value R, you make the other two resistors some factor A times R, so that you've got two equal resistors on the inputs and the other two resistors are equal as well, some factor A times R. Then the output, V out, is gain factor A times V1 minus V2. Again, you could go back to the big kludgy expression for the more generalized circuit and show that this is true, or you could analyze this one from scratch, which, if you really enjoy doing things like that, I would encourage you to do. But your book does a pretty good job, like I said, so I'm not going to bore you with that here. There are some problems with this circuit, which are not perhaps obvious on the surface unless you have dealt with differential amplifiers before. In a couple of modules, we will look at an improved circuit that handles some of the problems that this one does have. We'll talk about those problems and show how to resolve those. And that gets to be a little bit more complicated. But for now, until then.